and I also serve in a leadership role with the Global Power System Transformation Consortium, or G-PST, whose mission is to bring together key actors across the globe to catalyze a rapid, clean energy transition at unprecedented scale and speed. This is being done by providing a coordinated and holistic approach to the necessary knowledge, education, and support to power system operators across the 5 action pillars. The foundation of the G-PST is a group of 6 system operators from around the globe who are facing higher penetration of wind and solar inverter-based resources sooner than any other operators in the world. The 5 pillars of the consortium include research and peer learning, technical support, workforce development, technology adoption support, and standardization, and open tools and data. ESIG is the lead on Pillar 1, and more information on the G-PST can be found at globalpst.org. As lead on Pillar 1, ESIG would like to welcome you to the November monthly webinar of our joint G-PST Pillar 1 ESIG webinar series. This series is in addition to the regular ESIG monthly webinar series and focuses on the G-PST research agenda and associated topics being addressed in Pillar 1. Topics are presented by both the founding system operators and other advanced system operators active in Pillar 1, as well as members of industry and the research community participating in the G-PST. An additional series of webinars on the other 4 pillars of the G-PST is also being provided on a monthly basis through NREL. For those of you who would like to learn more about the G-PST and how to engage, please go to globalpst.org and click on the Get Involved tab. For further information on ESIG, go to esig.energy. Next, I'd like to go over a few logistical matters before we get started. First of all, phones will be muted for the duration of the webinar to avoid unnecessary distractions. For the Q&A, we'll use the Slido platform at slido.com. To ask a question, please navigate to slido.com and enter ESIG20 as the event code. The instructions are also at the bottom of the screen. You'll see a thumbs up button next to the questions on Slido to allow you to cast a vote to help prioritize the questions submitted. We plan to save about 10 minutes for Q&A at the end and then wrap it up at the top of the hour. An email with a link will be provided once the video file has been posted. We also plan to provide short responses to unanswered questions after the webinar, so please don't be afraid to ask your questions through Slido. Today's topic is on the European experience with Connect and Manage. As you might imagine, Europe faces a similar problem as we do regarding the need to interconnect an ever-increasing number of wind, solar, and battery plants on a system that has limited interconnection capacity and has a hard time keeping up with the demand for new connections. In Europe, Connect and Manage has become an approach used by some system operators where firm access is offered before all associated reinforcement works are completed. Today's webinar will give an overview of Connect and Manage principles, the experience gained from the common approaches being applied, and the learnings and best practices to be used in the future by system operators and policymakers. It will be presented by Mark Norton, Vice President of Business Development at SmartWires. Mark has worked in the international electric utility industry for 35 years, both in the transmission and distribution business sectors. Previously, Mark worked for both EirGrid, the Irish transmission system operator, and UKPN, the largest distribution system operator in the UK. Mark is a busy man. He's also the vice chair for the Current Association in Europe, an active member of the Watt Coalition, and the EU's European Technology Innovation Program for Smart Networks. He previously chaired the ENSO-E team developing the European 10-year network development plan and the development of 3 EU regulations on connection requirements for generation, demand, and HVDC infrastructure. I greatly value Mark's leadership and contributions to the industry and the energy transformation, and I look forward to hearing what he has to say. Okay, just a short reminder once again to use Slido at slido.com with the event code of ESIG20 to ask your questions. Let's go ahead and get started. Mark, I will now turn it over to you.
Thank you, Charlie. That's a very welcome introduction. That's very kind of you. I'll just try and bring up the presentation. First, thing to be overcome today, and then we can get started. So good day, ladies and gentlemen, and it's great to be able to talk to you here today. As Charlie said, I'm going to share the European experience with Connect and Manage. What I intend to try and cover over the next 40 to 45 minutes is to talk, and I'm going to spend a little time on this, the justification for the introduction of Connect and Manage. I'm going to talk a little bit about the definition of what we mean when we talk about Connect and Manage itself, the basic method that's actually being applied, and then dive a little deeper into the Great Britain's experience, what's happening in Ireland, and then widen out a little bit to wider Europe. I think it's important to mention at this point that Connect and Manage is relatively new approach in the experience within Europe, and there are other approaches that are being looked at as well, and we'll touch a little bit on those. I'll talk a little bit about the key risks, because with every connection method there is always going to be risks associated with it, and then some of the tools that can help to support and manage those risks and the process itself. And then finally, I'll conclude with what I would take to be the best practice approach based on what we've seen to date. So, to start, just looking at the journey, if you will, that system operators have had to go through in regards to connecting methodologies to the system. We started off way back when times were much easier, and there was a large amount of latent capacity on the grids across Europe and probably globally as well. And in that situation, all reinforcements were associated in the connection method, and the connection method offers in order for you to obtain firm access. And the main reason why that approach was able to be taken and sustained was the fact that the risk for developers was very, very low. The number of reinforcements was small. The scale and length of those reinforcements were more or less aligned with what would be required to develop the connection, and also the generators themselves. I mean, in most situations, the generators would have been very, very large. We would be talking about fossil fuel conventional generation. And therefore, the system and the connection method really was unchanged for many years and decades. But with the introduction of renewable energy and with the move towards the need to accelerate some of these connections, what we actually saw was that applying that process of looking at all reinforcements being associated before you could get firm access and as part of the connection method, ended up with the lead time for reinforcements rising. We ended up in a situation where there was a lot more reinforcements to be done. The processes that were required nationally for developing these new reinforcements really hadn't geared up for the change that was starting to occur as we moved towards renewables. We saw shorter construction times for generators. A lot of these generators were a lot smaller. They were more easy to construct and quicker to be brought onto the system. And long generation queues were actually starting to form. New government targets are being introduced, and there was pressure being brought upon, making sure that we actually met and delivered against those. And developers had started to walk away from projects. They were trying to get a timely connection from their perspective. They thought it was very reasonable to have a very short turnaround period based on what they've seen in the past. With all of this new pressure that was brought to bear, the longer reinforcement times, etc., then they found that their business cases were being eroded very quickly, and they were walking away. But, and this is important at the time, congestion was low. So as a direct result, there was a move to offer non-firm connection methods. So we won't give you the firm capacity, but hey, your congestion is going to be very, very low as a result. The risk that you're taking on is very, very small. It might only be 1 or 2 or 3% congestion over the period of congestion over the entire year. And as a direct result, even though the developer saw that it was a slightly higher risk, it was acceptable. Time moved on again, and what we'll find, I think, is, and the people on this call undoubtedly are thinking about their own national experiences. You will find that somewhere along this process is where you are at the moment, but the process is really being mirrored around the whole of Europe, and I expect around the whole of the globe. So moving forward in time from the non-firm connection method, which was, it worked and it was very, very sufficient to deal with that situation. As the ramp really started to rise in Europe, and we saw the fact that we were going, multiple gigawatts, hundreds of new generators being connected simultaneously, the complexity and the number of the offers shot up again. We ended up with a huge amount of constraint on resources in order to try and manage these offers. And as a direct result of the existing capacity being used up on the grid and the shallow connection, so the assets required to connect you into the network, the good ones being used up, we are having to develop new stations, new lines, new connections. And a lot of those were in areas where there was a lot of new generators coming in and they were sharing assets. And as a result of each of these offers being independent, we saw that there was a cascading of these offers. So, generator 1 came in, they were giving a capacity by a certain date using a certain number of reinforcements. And then generator number 2 would come along in that area, and it says, well, depending on what generator number 1 does, you'll have this. And if generator number 1 does that, if they accept their offer or don't accept their offer, then this will be the different set of reinforcements you have. And then by the time we got to generator 3 or 4, the offers were very complicated and cascaded, and really you didn't know where you were, and it was getting very, very difficult. And as an outcome, there was a move to clustering of connections. So looking at a number of generators simultaneously as a group, and this new method was brought forward. And again, that was brought forward for exactly the same reason as we'd seen the non-firm connection method, reduction of risk, to get it to an acceptable level for developers to be able to commit. What we've seen in more recent times, and I think Charlie alluded to it right at the very start, is the fact that, time has moved forward again. And yet again, we've got to a situation where the reinforcements that may have been taken 3 or 4 years and then grew to maybe taken 5 or 6 years, particularly if they're at the higher voltage levels, the 220 or the 400 kV system, now can be in the order of decades to be developed. The typical lead time is well over 10 years. And as a direct result, we're seeing that the number of reinforcements that needing to be done on the system has grown exponentially as well. A lot of the network now needs to be reinforced. We've used up all the spare capacity that we have on the grid, and there's a massive build program that's being required, and the constraints are extremely high for developers in that environment. And we're not talking about 1 or 2% now. We could be talking into double figures or more. We also have an extremely heavy push from a societal point of view, with higher and more aggressive government targets. In Europe, we've now got new targets for 2030. People are even looking beyond that. At home in Ireland, we're looking at 80% plus of our energy being met by renewable means. We're an island nation, so we're effectively trying to support that within an isolated grid. This is a sea change that's never been seen before. We also have seen across Europe that are a number of what we call zombie projects. So projects that really are never going to proceed, and they've actually been there and clogging up the queue. And that's one of the things that have been experienced in some of these countries. And as a direct result, we've got to this situation again where there's a reduction in the certainty of projects to the point where we need to intervene and we need to reduce the risk to make it acceptable again for developers to commit. And manage and connect is the fourth step effectively in that process. In the fullness of time, we may have another, but this is probably the most forward-facing method of connection that's in existence in Europe today. It's relatively new, as I said, but it's starting to grow and gain traction. Okay. So, having given you a little bit of the etymology of how it's come into existence, let's just talk about what we're talking about when we're talking about a collect and manage process. And I'll use connect and manage. There are other terms that are used out there, but connect and manage seems to be one that's relatively easy understood, and I think it's quite intuitive. It's essentially a connection process for the connection of generation, which allows firm access to the transmission system without the completion of a full range of reinforcements that would normally be required to meet the network's security standards or planning standards. And for those, for the avoidance of doubt, firm access generators will actually be paid. They'll be financially compensated if their output is moderated in the market. If the system operator intervenes and says, "I'm going to apply a constraint on you, you will get financial compensation." So this is quite a new leap. You're actually getting paid, even though what would have been the normal range of reinforcements required to meet the system standards are not in place. The basic method for doing this, and it's used more or less across Europe where it's actually applied, you have to divide your works into two categories. There's the minimum transmission reinforcement works that are going to be required, and that's before you'll grant access to the transmission network, or for that matter, distribution network. So before you allow the generator effectively to connect and operate in the grid and effectively get firm access, there'll be a minimum transmission reinforcement works that are required. There is also additional transmission reinforcement works that will be required on top of that, or distribution works, that will be associated to reach full compliance with the transmission system security planning standards. In order to try and create those two categories so that it's, we can effectively work out what's required to be firm, the transmission system security planning standards are well known and are exactly the same as would be used in any other generation connection. But the minimum works are usually based on a reduced criteria for connection. Now, that obviously involves the works that are necessary to create the physical connection to the transmission system. It could be a new line, it could be a new station, or associated works. But it's not necessarily restricted purely and simply to that. There can be additional works that are included in that criteria. And the example I've given is network stability reasons. So I'll talk a little bit more about one or two of the applications of Connect and Manage and what they comprise. The connection timescale is defined by the completion of those minimum transmission reinforcement works. And obviously then your firm access is granted. But whilst the additional transmission reinforcement works are not required in order to get firm access, they're often started and completed in parallel. But because of the lead time for what is generally a larger scope of works, a lot more infrastructure is needing to be developed, and often bigger projects, they're often completed well after the firm access has actually been granted. So there's a lot of works that are still residue and continuing, and it's an important point to bear in mind when we talk a little bit about what happens over the course of time with Connect and Manage. So to dive a little deeper into probably the place where Connect and Manage has been used for the longest and is the most mature, We'd start in Great Britain, in GB. It was introduced onto the transmission network in 2010. The term that they use, the division of works between the two categories that we talked before, is enabling works. So that's your minimum transmission reinforcement works. But they also have what they call wider works as well, and those are required in order to meet the security standards, the NETS SQSS, so system quality standards in the UK. But the enabling works was probably the more interesting one, the minimum transmission works, and to evolve that discussion, that piece I mentioned about that. Look, is this just the works that are required to make the connection? You can see when you look below that yes, there are works that are required for the connection. So, and those need to work in the intact network operation to ensure that all the network equipment is within ratings. So once the connection is made, you should be able to run the network with the additional generation and not at any point in time across the normal cycle of load and demand that's changing, end up with the equipment ratings being breached for going above or beyond what they're capable of. Voltage should be within the normal limits and performance margins that would be specified anywhere else in the grid. System stability must be maintained. So it should be, it should not be allowed for, oh, so I've just seen maintain system stability, not instability, apologies. And not create any unacceptable subsynchronous oscillations. And you can see from just that list alone that there's nothing there that restricts it purely and simply to assets that are required just to connect, or equipment that's required just to connect the generator into the network. It can stretch beyond that. If there's instability elsewhere in the network, that may need to be resolved first. So it could be quite remote from the generator. Generally not the case, but that is allowed for. The same with subsynchronous oscillations, as everyone knows. They're not generally isolated. They can be over quite large distances. So whatever's required to mitigate or avoid those could be at a remove, shall we say, from the connection point. The other side of the enabling works also looks at taking into account what would actually happen on the system, and the for certain faults. Clearly, you've got potentially a very large generator, and certainly the generators have been growing in size over the course of time. You have the potential in many situations that you could be losing very large generator infeeds, particularly as we move into the offshore world. And in GB, they're looking at 50 gigawatts of offshore connections. A lot of those are with 2 or more gigawatt connections or circuits coming in. And there's a requirement that that network needs to be able to avoid having an 1800 megawatt power infeed being lost. So that effectively defines, how much generation can they carry on each individual circuit. The 1800 megawatts is aligned with what change in power infeed would trigger a frequency event. So to change the network frequency, potentially to jeopardize system security. And at the same time, there should be a situation where no fault on the transmission circuit should actually create power to be lost as well. So those kind of define the number of circuits and the configuration of how you connect that generator in. There are other requirements that are there, but generally aren't used in order to define the minimum transmission reinforcement works. The transmission network must be able to be operated in a safe manner. Resolution of any fault level issues just means, obviously, that from a safety perspective, you don't want the new generator to cause issues that are over the capability of the network, but they clearly have to be resolved in advance as well. And then statutory obligations, the grid code, and alike, normal things that would be expected of generators connecting to the system. So that has eliminated an enormous amount of infrastructure that's required for generators actually to connect. It's significantly simplified the works that needed to be developed. Most of them are for connecting to the network, albeit, as I've mentioned, some of them could be more deeply embedded in the network. Certainly when Connect to Manage was first implemented in 2010, it was recognized that the associated works, the minimum transmission reinforcement works, were quite limited and almost exclusively at the connection point of the generator to the system. Over the course of time, however, that started to evolve into bringing in more reinforcements more deeply into the network. And that probably is an indication, as we've seen with some of those earlier generations, the move to non-firm connection, the move to clustering. Each time we move to a new approach, there's a period where things are quite easy and where there's a step change in the speed and capability to connect to the grid, and it works very, very well. And then you run into another set of issues, which then may trigger you to revisit and think where we're going to go to next. At the moment, Connect to Manage is definitely working very well in GB, but it is actually starting to end up with more works being associated as a result. But let's talk a little bit about what's actually been the impact. So the latest report, unfortunately, is only as far as October of 2015 that I could find, to try and assess what the Connect to Manage processes created in regards to the connection of generation and the benefits and issues around that. But it still is quite a powerful indicator over that sort of 4-year period. We can see that in totality, there was 255 generators that were connected. So that is a significant increase in the amount of generators purely and simply by the Connect to Manage process. In total, that was 42.5 gigawatts of additional generation that came onto the system. So if you look at as I say, the plans for the offshore, which are to try and meet the next round of targets that the UK has, you can see it's nearly matching that. One simple but yet again powerful change in the connection process has generated 255 generators, 42.5 gigawatts. Also, if you want to look at it from an environmental point of view, there's an estimation at that stage that 5.9 million tons of carbon had been saved. That is a huge step in the right direction if you're looking purely and simply from the carbon perspective. But probably the most telling figure for me, it's shown in the table, you can see the breakdown that's actually there, is on average, the connection of those generators was 5 years earlier than they would have been otherwise. And bear in mind, as I said before, this is in 2015, that assessment was done. It hasn't got any easier in the UK since. The capacity that's actually available has been reduced. There's more generators coming onto the system. So that 5-year average is undoubtedly only gone one way, which is higher. We've seen in recent times some of the key pieces of infrastructure being significantly delayed longer than they would have been before. So that would support for National Grid, that would support that 5-year average has only grown since then. And if we look at the 255 generators that were connected, 85% of those were renewable. So definitely it was targeting the right sector for what was actually being looked for from a government and regulatory support perspective. There was this want and desire to see the renewable energy penetration rise quite quickly. And the thing that probably is a big number, but in context is actually quite surprising, is the constraint levels at that time. the constraints were rising, but the cost of actually connecting these 255 generators early, this 42.5 gigawatts, was estimated at the time at 121 million pounds. And that was across the time period, so from February 2011 to October 2015. So it was a significant connection of generation with a relatively small impact on constraints. Since then, as we have seen more generators connecting under the Connect and Manage, and the infrastructure that's proposed to be developed, as I said, has been delayed, constraints have risen, and quite sharply as well. I think the last figure was around about 1.5 billion pounds in constraints in 2022. I think was the estimate that came in. Now, it covers more than obviously just these generators, but you can see that the the scale of constraints is rising. So Connect and Manage has definitely shown its worth. It's definitely got the right output, but as I say, there's a trajectory of travel on how far it can actually take you. Looking at a different approach and a different country, but probably the nearest one to Great Britain and the UK, is Ireland. And Ireland is really only starting to get to grips with the Connect and Manage approach now. It had a great deal of success with the clustering method. Its Gate 3 methodology had permitted probably 10 years of network generation development to move forward. But it's now running into many of the same issues that had been problematic elsewhere, rising reinforcement timelines and a slowdown in the progress and connection of new generation. In Ireland, Connect and Manage is referred to as the firm access methodology. The decision to move forward with it was taken earlier this year in January. And the terms that are used in the Irish connection works is shallow connection or deep. I know that's mirrored in a lot of other places. And it refers primarily to the assets required to connect the applicant's facility to the existing transmission system. That being said, it has many of the same criteria requirements that you would have seen in the UK, in Great Britain, from the point of view that fault levels would need to be included in that. The stability would have to be incorporated as well in order to make sure there's no instability on the system. But it is dominated, as with GB, on the shallow assets. The deep reinforcements in this case are complying with the transmission system security planning standards that EirGrid, the transmission system operator in Ireland, utilises in the development of the grid. Slightly differently in the fact that most of the shallow works, due to earlier legislation and approach and connection methods, is allowed to be built by the developer. And if the developer doesn't wish to build it, then it will fall back to the system operator and the asset owner to develop. But it does give another element for those who want to connect more quickly, once this process is really being used in earnest, for the developers to have a lot of it within their own control. The big difference is the fact that the system operator, like most system operators, defines a list of planned developments in its development plan annually, and it updates that, say, every year. And unlike the Connect and Manage approach in Great Britain, firm access isn't granted on the completion of those shallow connection works. Instead, what actually happens is the development plan reinforcements are used during system studies, and they are based on a set of dates that would be typical for building that infrastructure. And that is used to work out when firm access in a future year would be achieved for that particular generator. So you start from this year, you look at connect, can I connect all of the capacity of this new generator using system modeling? No, I can't. So you've got a year, another year, and new reinforcements are being added periodically according to the development plan. When you reach that firm capacity that allows that generator to be, granted, I have enough capacity on the grid that you've got firm access to the system for a normal range of operating conditions across the year or in future years, then you would come up with a date when that firm access would be available based on that development plan. There is a threshold that's being proposed at the moment. It's looking around about 20 megawatts. So you don't have to have 100% of the capacity available. It just needs to be brought down to a relatively low level. And as I say, 20 megawatts is what is being proposed. And final decision still has to be made on that. But assuming on that basis, once you get below that 20 megawatts, when that year occurs, you then have worked out when your firm access will be made available. The difference is the fact that previously, if those reinforcements were delayed, or if the system conditions changed to make that more onerous, your firm access would move with those changing circumstances. So if you needed an extra reinforcement, or if you needed an extra works, then your firm access could actually move further out because the reinforcements that were being planned may have been delayed. There may be planning issues, there may be whatever. And consequently, you could be, you have a high level of certainty, but there's a reasonable probability that your firm access date that you were expecting could actually be delayed. In the new situation and the new system, that won't happen. It'll be frozen. It will never get any further out. However, there's an annualized process that is being proposed that will take into account changes in the number of generators that may be on the system or looking for connection. So some generators may fall away. They may change the size of their plans. They may end up potentially with reinforcements being built earlier or more efficient solutions being found. In the annual review, if that firm access future date can be achieved earlier, so the new list of reinforcements would give firm access an earlier time span, then the generator would benefit from that, and the firm access would be moved to a shorter time period. And as a consequence, there are benefits that would be achieved through that. And you can see that what it's effectively doing is taking into account changes in the number of users that are looking to connect to the system. When they're releasing capacity in the network, you're actually backfilling that with new generation as quickly as possible, and they're benefiting from that change. When we look at wider Europe, so I've talked about probably the two more developed systems and where they actually are. There's a pathway to connect and manage that we're seeing, and I show the steps, from all reinforcements needed to be completed to shallow connection through to clustering and then connect and manage. A lot of people are in different points on the journey, but it's now starting to become things are being contemplated across wider Europe. In France, there's an option on the DSO side for what they're terming an intelligent offer. And that allows a generator that's already in a part of the system that's fully loaded, or there's no latent capacity, to be connected without any without needing to create any new capacity. So, like adding new additional transformers to try and resolve that constraint. And in return, the producer, so the generator, if it is curtailed, it can be compensated in the case of that congestion. So it's the same principle. Effectively, they're being made firm, but it is within the confines of a regulatory sandbox. So as a result, this is being tested. It's not something that's de facto across the entire of the French system at the moment. It may not become the norm, but it is something that's shown enough interest that somebody's created that sandbox in order to test this out. We also see a number of the large bodies out there that are recognizing, the way things are progressing, the way that Europe's going to go, or the systems are going to be asked to move in order to deal with this issue. And the issue is acute across the whole of Europe. I don't think there's anywhere where building infrastructure to keep pace with the generation connection is actually occurring. And those lead times for development are getting longer, while the generators lead times are not changing for developing and building their generation plant and equipment at the same pace. It's much faster for them. So what we see is that Euroelectric have identified that there's going to be an increasing move beyond the traditional role of building and connecting towards connecting and managing. So they see the fact that they're going to have to manage that as they go forward. And we can see the conclusions of the SEER paper. That's the one of the regulatory bodies in Europe is looking at alternative connection agreements, and I'll talk a little bit about them on the next point. But as a temporary instrument to connect new users that can only be connected on a firm basis once ongoing network reinforcements are realized. So what they're saying is the fact that, yet again, they can see the fact that alternative connection agreements can be used. And whilst they're not suggesting that firm access be granted early infinitum, it can be used as a stopgap before the network reinforcements can be developed. So very much the same concept, very much the same approach as we see with the other connect and manage methods. And whilst it doesn't fit the mold or the definition that I provided already for connect and managing principles, there's a much wider range of alternative connection agreements. I kind of like to look at them myself personally as being sort of a somewhere in between connect and manage and the cluster approach. There are a number of different things that can be done or are being done in these what they call alternative connection agreements. You can get temporary firm connection agreements, so you get a firm capacity for a period of time, and you can be compensated for that. There may be time limited firm connection as well, so you may end up with certain points in the day or the season where you're non-firm because the capacity isn't there, but at other times you're fully firm and you can operate in the grid, and you would be compensated if you were constrained or congestion was to occur. There's shared connection agreements, and you can see there's a list of another 4 or 5. I won't go through them all, but all of these are different steps or different stages towards a full connect and manage approach. And people are trying these. A number of these are in use across, you can see Austria, Belgium, Finland, France, Hungary, Luxembourg, Netherlands, Norway, and Sweden. There's a number of countries that are using these, or some of these, or all of these, as part of their development. It may be nationwide. It may only be in limited circumstances, but they are actually in circulation. So I haven't talked a little bit about where it is globally. Well, sorry, I shouldn't say globally, across Europe. Connect and manage does come with some key risks. I don't think they're terribly surprising ones, but it's worth just sort of spending a couple of minutes just running through them. So the first one is constraint costs. I mentioned before that constraint costs in the UK have risen significantly. In part, that can only be as a consequence of connecting a large number of new generators to the system without the full range of system reinforcements. It's not the whole story, but it's definitely a contributing factor. And what we tend to see as well is that, the constraint costs are rising with connect and manage, but constraint costs typically increase over time as generation increases as well. So it's not just that we've seen a rise with connect and manage, the actual putting the entire approach in any one year, you'd see a step change because it's coming in constraint costs. But as I say, over the course of time, over the last 10 years, that has risen proportionally with the number of people that are being connected. However, it's not all bad. There's a mitigation that's actually being brought through to society for that. So society's going to have to pay the constraint costs. There may be concerns about the fact that the price is rising, but there is an offset from that in the fact that you've got all of these new generators coming on. They're green. We would hope that they're very efficient. They're certainly going to change the makeup of the market, and we should expect a lower unit price of electricity than what we would have had as a direct result. And a secondary thing, and certainly it's a concern in and around Europe, is the fact that there are penalties for failure to deliver national targets. In July this year, France were at risk of not delivering their renewable targets. And there were other countries as well, but France got to the point where they were having to go around very rapidly and find megawatt capacity credits from other countries. And they were looking at spending around €500 million, not a trivial sum, in order to try and make up that shortfall. So there is an offset there. Constraint costs will rise, but price of electricity is impacted, and you're avoiding penalties. If we look at network security, again, the impact is with the higher utilization of the network assets, you can see that there's a potential increase for the severity and the quantity of failures. You run a network harder, you run a network at much more higher load, you can end up with scenarios where you're going to end up with something that's bigger problem than it would have been before. And the more hard you run equipment, generally the more breakdowns you're likely to have. So there is that impact. Plus the redundancy in networks is reduced in the fact that a lot of these deep reinforcements are being built, but they take time. You are connecting new generators under connect and manager in the same area, most likely. So you're trying to run the network with less redundancy built in. But there's a mitigation yet again for that. So the very nature of connecting these new generators means the fact you've got a more diverse generation portfolio. You've got wind, solar, storage, and it's also in the different locations. So now you may have generation in places where you didn't before, and that, as a direct result, can mitigate and help manage until new solutions are being delivered. And it gives you more choice than you would have had before in the way you manage around those situations. And then GETS technology, and I'll talk about this a little bit, can help improve stability as well. So some of the other tools may assist. And just to talk a little bit about support tools. So the last point I just mentioned was grid enhancing technologies. A point very close to my heart anyway. There are a variety of types out there, but they can help with connect and manage and support the situation while you're trying to develop those longer term reinforcements. They can be a good stopgap, but also they can contribute to the reinforcements when they come as well. So you get this sort of continuous gift. Potential, and the reason why they are a significant new tool that can be used in this new environment is primarily their speed of delivery. We're talking about 1 to 2 years, but also their scalability and flexibility and the fact they're reusable solutions. So, we've already talked about the high levels of uncertainty that we have and how that's influenced the number of the decisions that are being made by generators actually connecting, and that's what the connect and manage was there to support. Well, that doesn't go away, but it still needs to be managed by the system operators. These kind of tools are very useful for managing those kind of issues. And it also can give security to the network. If you have rapid changes in demand, you see a trend that didn't come through that you thought you were going to have, or you run into some real difficulties in public planning and trying to get approvals of building things, or a market-driven fleet closure. So you connect on this generation, you might end up with widespread disconnection of coal or gas or other forms of generation. They can help in that. Just as an example, I've thrown here in National Grid in the UK and ESO, because we were talking about connect and manage primarily in GB, they are using modular power flow control. It is providing 1.5 gigawatts, and it's been rescaled to 2 gigawatts of capacity. It's delivered in around about 2 years, so there's more potential there. But one of the reasons that it was developed is due to a significant connection of new renewable generation in Scotland and the lack of capacity between Scotland and the rest of the UK. It obviously, with this faster development times, has really aided in managing that in and around the region. So there's an asset example of these types of technologies supporting a connection and manage approach. Another connect and manage tool is been implemented in Western Power Distribution. They brought the same title unusually, but a connect and manage approach for distribution and distributed energy resources. What they essentially did is they said, well, look, customers with an export capability 1 megawatt or more, they were obliged to have automatic network management so that it could be controlled. And it gave visibility as well, so that it could be used for transmission constraints, but also for distribution constraints as well, both the ones that existed at the time, but also into the future for emerging constraints. It was a market-based procurement, but they looked for backstop prices for compensating for flexibility. So essentially, you were given the option to do it on a market-based bidding in for procuring it. But if you wanted to not have the complexity, you could fix a price and then be used against that. And the real joy in this is the fact that it allowed some of the issues that were being managed in the real time to be dealt with, but effectively it was under the same premise or concept of the connect and manage process we've already talked about, which is getting people on the grid quicker without the necessary reinforcements. However, if you're a developer and you didn't want to do that and take that approach and try and look for what would have been a lower cost connection, you didn't want that concern, you could go back and have the full set of infrastructure, transmission works or distribution works applied, but you'd be paying for the full cost of those reinforcement works to be completed. So, it was a way to reduce the costs and at the same time support the grid, but you weren't forced into that. It was an option. And then finally, and I know I'm just a little bit over time, just to talk about, in summary, what's the best practice approach to connect and manage. The first thing is the introduction should be considered when you're in a situation. So we've seen this sort of pathway going forward. To some extent, there's no point in implementing it early. But when you get to the point where you're seeing, market generators that are trying to connect onto and come into the market are exiting, and when you investigate that and find that the reason that they're leaving is because of impacts of reinforcement lead times, it's just taking too long. And that obviously has a knock-on impact in regards to the costs of investment, the interest rates that can actually rise, and when you're seeing a sort of stalled progression of the government targets and where they actually want to be. So you're progressing on nicely, and suddenly it comes to a grinding halt. You're not getting those new connections coming on. Government targets are at risk. There's a cost attached with that, as we already said, both environmentally, politically, economically, but also potentially financially. And there's a couple of common signals that comes through. when you've got constraints that are too high for people to look at things like non-firm connections, they can't in truth come in and await those reinforcements to come and invest early. That's a big signal. And similarly, if there's a failure of developers to be able to get the funding they need to be able to sustain it, when you're seeing people taking losses effectively because the investment costs are too high to proceed, given the level of uncertainty or just the cost themselves. So those are both, big signals to say, look, we should be considering going to connect and manage. The next big element and sort of is assessing the balance of risk and how you're going to split that between society and generation developers. And sorry, I say generation, it could be storage as well, of course. But consumers must take or shoulder some of the investment risk with developers. That's a balance that alters over the course of time, but realistically, there needs to be some real sort of sharing between the two. It can't be all loaded on the developers. And trying to get that balance, there's a technique, or there's some techniques that have sort of shown through that might help there. So the first is you can look at a progressive approach. So you could mix the Irish and the GB or the UK approach, and introduce a connect and manager connection approach that starts with only deferring part of the constraint period. So as we've seen before, I've talked before about the deep reinforcement dates from simulation, and you get that frozen, and if they get delayed, you're covered. But as time progresses and the system and the issue becomes more difficult, then you can move to the UK approach and effectively cover for the entire, and make your firm from the day one and cover the entire constraint period. And a way to actually show when to move forward on that, or when you haven't invested or got that balance right, and you need to re-evaluate it. Reporting and feedback is key. And it allows you to make further intervention, but it also allows you to have the justification for making that further intervention. And the whole point is you want to bring stakeholders in society along with you on the journey and make sure that they're bought in as well. And you can have an emergency stop built in. So if you find that you've gone too far and you've given out too much, you can just stop the process, wait, and then come back. And then finally, justifying the societal value. I mean, obviously part of this is making sure that, as I said, that society is with you on this, and stakeholders, whether it be governmental, political, or whether it be regulatory, there has to be an understanding of what the cost of failure to deliver is, whether that be, like moving to 2050, the targeted requirements, the conventional energy costs that you'd actually have to pay without the generation that would come from connect and manage. And there needs to be transparency in that as well. It needs to be very easily understood how those are calculated, so that people can feel confident that what you've said is a cost of failure is reasonable and well justified. And the other thing, of course, is to make sure that's open to all. We talk a lot about renewable, but connect and manage should also be not restricted to purely renewables themselves. So I'm going to stop there. I realize we're virtually at time, so hopefully I finished just in advance. But Charlie, I'll hand it over to you on Slido.
Okay, thank you, Mark. I'm going to let us run another 5 minutes anyway. There's a lot of questions that have come in, a lot of good questions. I'd like to get to some of them at least verbally with you. So one that's risen to the top. Do I understand correctly, this system effectively rests on the ability to compensate generation for curtailment? I think the answer to that is obvious. And yes. Who pays for that, and how is that payment structured?
So the payment is society, so it's the consumer at the end of the day. And the way that the payment is structured is that typically it would be paid at the market rate at the time when the constraint is applied. So when the system operator intervenes and says, I need to make a change to the market dispatch that would have come out from the normal clearing, then whatever that unit cost is what would be payable back to the generator.
Okay, and I'm going to ask a related question right now, even though it's lower down. Is Europe looking to LMP markets as a better way to manage congestion rather than relying on the single zonal prices with uplift payments?
There's two schools of thought there. So it's definitely a war that's still ongoing. I don't think anyone has won out. So, locational signaling is definitely something that a lot of people are very interested in, but it comes with consequences, of course, when you move from the zonal market. And there's winners and losers, and you can probably guess who's backing which side, in which approach. So, yeah, it's kind of related but unrelated at the same time to obviously connect and manage. It can work in either.
Okay, maybe a quick question here. ERCOT. ERCOT's Connect and Manage leaves congestion risk with generators through an LMP market. Is the European payment for congestion just how congestion management works there?
Sorry, just missed the last bit there, Charlie. Can you just repeat the last half sentence?
Yeah. The first part says that ERCOT manages it by putting the risk on the generator through the LMP market. And the question is this payment for congestion just the way you do it in Europe? Is that just how it works?
Well, it's really the principal key difference. I mean, the point is with the firm access, you are getting that congestion. You're getting that constraint payment back. There are plenty of other situations. I mean, if you wanted to go non-firm, you effectively expose yourself to the risk of not getting constraint payments. But the difference between Connect and Manage is the fact that you are made whole from day one. Well, in the UK, you're made whole from day one. Obviously, you've got a certainty if you look at the Irish method in the fact that, whatever your backstop, whatever the date is for firm access from day one of your connection offer, it can only get sooner, it can't get later. And you're going to be, whatever curtailment occurs after that, you're going to get paid for.
Okay. Interesting one here. How has transmission planning changed, if at all, since the implementation of CNM and GB for UK?
I mean, and this is a very, very personal view, but I think that it has actually been a great driver for innovation. The existing development of transmission projects obviously still continues, but it can't continue just using conventional technologies and conventional approaches for developing the network, because the cost of not developing that network more rapidly is now becoming increasingly large. And as a direct result, there's more riding on it. So if anything, it's really sort of triggering and spurring innovation. But that's a very personal view from my viewpoint.
Okay. Interesting one about IBRs. How have you managed the competition risks and the growing sequence of IBR connections occurring in close electrical proximity? And maybe that's referring to the stability problems or control interaction problems or oscillation problems. I'm not sure.
Yeah. So yet again, I mean, if you're looking at and the outcomes, if you've got a high level of renewables coming in, you're getting a reduction in system strength. You've got a higher risk, obviously, of having controller interactions and or things like subsynchronous, oscillations occurring. Some of the tools I mentioned, like the GETS technology, can manage that, and it can mop up those problems as they occur almost in real time. But similarly, as I've said, if you're looking at the minimum reinforcements, so the ones that are actually envisaged or seen to occur on day one, so the day that the connection is actually going to be made or at the time the analysis is done, they are actually associated with those minimum transmission reinforcement works. So whatever can be seen at the outset is resolved, and there could be any form of conventional reinforcements that would be put in place to do that. So whether it be, StatCom stiffening the network, synchronous compensators, whatever it may be, to manage that. But in the longer term, if they occur, then because of that move, then you're looking at using things like GETS technology to try and mitigate that in the near term.
Okay, I'm going to take one more question. I'm going to skip down to the bottom, and because there's a number of questions on GETS down there, and they're obviously of interest. Are GETS being looked at as one of the reinforcement options by transmission planners in the UK? And are there additional operational risks with the implementation of GETS pushing operating envelopes closer to the threshold?
That's a great question. So to answer the first point, are they being considered? Yes. Have they been implemented? Yes. Have they already expanded that deployment before we even finished building the first round of GETS? Yes. And the example I gave you in National Grid, we put in projects on 5 lines in 3 locations, and we actually expanded the size of the deployment before we even finished it. Are there more planned beyond that? Yes, there certainly are. If you go to the network options assessment for National Grid, you'll see there's a lot more that are planned in the longer term. And as a consequence, they're helping to sort of manage this situation quite well. And do they have any issues because they're pushing it closer to the limit, to the envelope? The answer on that is no. And part of the reason is because if you use the GETS, you can increase stability margins by using the GETS that you've deployed and some of the technologies in one location to try and mitigate any of those issues as they actually arise. So the solution, in one sense, is actually the cure. Does it create a higher utilization? Yes, but at the same time, it gives you more room to maneuver, more room to operate, and more tools to bear to manage those higher levels of operation. And in some cases, bear in mind, things can be, for example, modular power flow control could be capacitive as well as inductive. You can even reduce things like, losses or move yourself away from resonant points that may be occurring or harmonic or power quality issues. So, yeah, it's a complicated one to answer, but it solves as many problems as it creates, and it can actually solve some of the problems it creates at the same time. I haven't got long enough to explain that properly, but yeah, I wish I could.
Okay. Well, thanks for that, Mark. We're a little past my 5 minutes past the top of the hour, so we really need to wrap it up. And I want to thank Mark for this really informative webinar on the European approach to connect and manage. I think we all have a lot we can learn from it. And as I mentioned earlier, an email will go out once the video file has been posted, and we will answer the questions we didn't get to, and there's a fair number of them, and get them posted as quickly as we can. So we appreciate your participation, and if you'd like to stay engaged, I'd like to invite you to participate in the next ESIG webinar on November 28th on DER communication and data management, a topic much talked about in the industry today. I'd also like to invite you to attend the ESIG Spring Technical Workshop in Tucson the last week of March, which will be here before you know it. Further information on all the webinars and events can be found on our website at esig.energy under events, and you're all invited to attend. Information on all the G-PST webinars can also be found at globalpst.org. Mark, I want to thank you again for this very timely webinar, and thank all of you for your interest. We look forward to seeing you again in the near future. And in the meantime, everyone, take care, stay safe, and thanks again for your participation.
Thank you.
Thank you, Mark.